In this lesson, we're specifically talking about congruent triangles, and a reminder that congruent means that things are the same size and same shape. We've used this a lot with segments and angles, but now we're applying it to triangles because triangles are just a conglomeration of angles and segments put together. All right, so the corresponding parts of congruent triangles are just going to be the matching congruent angles and congruent sides of congruent shapes. So this works for triangles and any other shape that is known to be congruent. So for example, if I write a congruent statement for these two triangles, notice that all of the angles are congruent and all of the sides are congruent. So when I make a congruent statement, I have to say, if I say triangle ABC, I have to make sure that when I say the next triangle that I put it in the appropriate order. So if I went ABC, A is the triple arc, and that would coordinate with the P over here. So the first letter I do in the next one would be P. And then since B is my second letter, I have to make sure this is this double arc, and that corresponds to the Q in the other triangle. So my next letter would be Q, and then R and C correspond. They match up with each other. So that would be R. It would be incorrect to say triangle ABC is congruent to triangle QPR. That is not okay because the letters do not match up. Okay, so now when they say identify all pairs of congruent corresponding parts, they mean list all the angles that are congruent and list all the sides that are congruent. So I would say, well, angle A is congruent to angle, angle Q. And I should be able to get this information from that congruent statement. I was looking at the wrong congruent statement. That's why I'm messing up. All right, so angle A is congruent to angle P. Angle B is congruent to angle Q. And then angle C is congruent to angle R. Now for the sides, I can say AB, which has the triple, is congruent to side PQ. So AB, put a segment over it, is congruent to side PQ. And again, I should be able to get that from my congruent statement. If I go AB, then I should go PQ. You should not say AB is congruent to QP. Even though it's the same side, I need to go in the same order. Okay, then if I do AC, that's the first and the last letter in my congruent statement. So then I would do the first and the last letter of that other triangle, PR. And then the BC is the last two, so I would use the last two in the second part of the congruent statement, QR. So be very careful when you're doing your congruent statements and stating which segments and angles are congruent. You got to go in the correct order. All right, so let's say you already knew that these two triangles were congruent and they have this congruent statement. Pause the video right now, see if you can pay attention to detail and write the correct corresponding sides and angles. All right, so your angles and segments should match up exactly with mine. They can be in a different order, like for example, you could have listed this one first, but they should be matching up accordingly. So how can we use this? Well, if I know that these two quadrilaterals are congruent, and we're trying to find the values of these missing variables, then I have to make sure I'm matching the things up that go with each other. So X is this side here, NM. So that should match up with GF in the other one. GF is 12. So I would know to set 5x plus 2 equal to 12 and then solve. So I'm getting x equals 2. For the y is this angle L. So L corresponds to angle E. So that would be 111. So I would say 5y plus 6 equals 111. Subtract the 6. And then divide by the 5. So I'm getting y equals 21. So that's how you can use your congruent statements. We also have a handy theorem called the third angles theorem, and that's useful in triangles. So if I know that two angles in the two triangles are congruent to each other, then I know that the third angle, C and F, would have to be congruent. And that's because of that triangle sum theorem. If they all have to add up to be 180, and we already know the first two are congruent, then that last one should be congruent. So for example, if I find what these are, let's see, 67 plus 54, that would be 121. And if I subtract that from 180, that will be 59. So I know that this third angle is 59. And notice that they already marked the double and the single arcs congruent. So this third angle has to be congruent to this third angle. So I would know that 4x minus 5 is equal to 59. So if I add that, I'm going to get 64. And then divide by 4. I'm going to get x equals 16. So that's our third angles theorem. And we can also use that in proofs. So for example, look at all this stuff that we're given. We're given SV is congruent to RV. Ooh. SV is congruent to RV. That should be a single. And then TV is congruent to WV. And then ST is congruent to RW. So that's the triple. So all the sides are congruent, and then they also tell us that the angle T is congruent to W. So we're trying to prove that those two triangles are congruent, so we just really need to show that these remaining angles are congruent. And look at the ones at the V. What kinds of angles are these? These are congruent because of vertical angles. All right, so that's what we're going to write in our proof. So all of that stuff in the beginning is given. And then SVT, okay, so when you use three letters, trace it out. SVT is congruent to RVW. All right, so that's because of the vertical angles theorem. And now that I have two angles congruent in both triangles, then I can use that third angle theorem to show that those last ones are. So this is a handy use of the third angle theorem. And now I can say that these two triangles are congruent because that's the definition of congruent triangles. When all sides and all angles are congruent. So the properties that we've been using for angles and segments, the reflexive, symmetric, and transitive, that also works for triangles. You don't necessarily need to write down everything, but maybe just know that all reflexive, symmetric, and transitive works for triangles. What we're going to be doing in future video lessons is finding some shortcuts so we don't have to always prove all three sides and all three angles.